Alaikum sir, I am Muzafa, a student of grade 8. I request you to kindly explain the concept of rational and irrational numbers to me in a simple and clear way. Thank you so much sir.
Bismillahir Rahmanir Rahim. Thank you, Huzefa. You have asked me to explain rational numbers. If you remember, in one of our videos, we have already learned number system. And in the number system, we have learned natural numbers, whole numbers, and integers. You know, the natural numbers start from 1 and go on forever, unendingly, and then whole numbers start from 0 and they also go on unendingly, they do not end. And then integers are the numbers which include the natural numbers 1, 2, 3, 4. They include 0 also, which is a number of set of whole numbers 0. And then integers also include negative numbers. So we have already learned natural numbers, whole numbers, and integers. Now, if you look at the natural numbers, they are all present in the whole numbers. You can say that natural numbers are a subset of whole numbers. But all whole numbers are not present in natural numbers. So, whole numbers are not a subset of natural numbers. But natural numbers are a subset of whole numbers, and we write it like this. Natural numbers are subset. This is the symbol of subset of whole numbers. Right? Now, whole numbers are a subset of integers 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, and so on. So we can write that whole numbers are subset of integers. Whole numbers are subset of integers. When natural numbers are subset of whole numbers and whole numbers are subset of integers, it means natural numbers are also subset of integers. So natural numbers are subset of integers 1, 2, 3, 4, so are 1, 2, 3, 4. So natural numbers are present in integers. So natural numbers are subset of whole numbers are subset of integers. But integers are not subset of whole numbers because all integers are not present in the whole numbers. The negative numbers in the integers are not present in the whole numbers. So integers are neither a subset of whole numbers nor natural numbers. But natural numbers and whole numbers both are subsets of integers. Now, if you allow me, I will erase it so that I can write something about the rational numbers. Now we come to rational. The fourth category is rational numbers. Now, what are rational numbers? Rational numbers are the numbers which can be written as a ratio of integers. As a ratio of integers. Integers. As a ratio of integers. I mean, 1 is an integer and 2 is also an integer. So, this is a ratio of integers or a fraction of integers. We can also say rational numbers are numbers which can be expressed as a fraction of integers. So, 1 is an integer, 2 is also an integer. So, the rational numbers are basically fractions. They are fractions. But fractions are what? Fractions of integers. It means we have negative numbers in integers also. So, we can also write like this. minus 2 over 3 or 4 over minus 7. This is also a rational number, this is also a rational number, and this is also a rational number. Or 0 over 4, because 0 is also an integer. You have seen in the set of integers 0, positive numbers, and negative numbers. So, what is a rational number? A rational number is a number which can be expressed in the form of a fraction like P over Q. P over Q. P over Q. Now, P is numerator and Q is denominator. Like 1 is numerator, 2 is denominator. So, the fraction line, the top number of the fraction line is called numerator and the bottom number is called denominator. But when P and Q are integers, P is also integer and Q is also integer. But here is a distinction which I will make. Q is a non-zero integer. P is an integer, but Q is a non-zero integer. Non-zero integer. Now, what is a non-zero integer? It means that P and Q are integers, meaning thereby that P and Q can be 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Q can be 1, 2, 3, 4. It can be minus 1, minus 2, minus 3, minus 4, but it cannot be 0. Therefore, I have written here non-zero integer. Q is non-zero integer. Q can be any integer except 0. It cannot be 0. So now the definition of rational number is the complete definition. A rational number is a number which can be written in the form of a fraction P over Q, where P and Q are integers and Q is not equal to 0. This is the complete definition. Now let me write it in the form of a set. Look, integers are represented by Q. Q. Natural numbers are represented by capital N, whole numbers by capital W, integers by Z, capital Z. And I told you last time when I delivered the lecture on number system that Z means Zahlen, which is a German word which means numbers or integers. Zahlen. So Z is from Zahlen. And Q is from quotient. This is also a German word. Quotient. Quotient. What is quotient? When you divide a number with another number, the answer you get is quotient. And when you divide like a fraction P over Q, that is numerator over denominator, what you get? Quotient. That is why it is shown by Q, quotient. Okay. Now, how to write it? Quotient is rational number. A rational number is a number which can be written in the form of a fraction like P over Q, P over Q in the form of P over Q, where we put this line, straight line, vertical line, where P and Q, for and we always put comma. P and Q are integers. P and Q belong to, this is the symbol of belong to. P and Q belong to integers. Z belong to integers. Yani P and Q are integers. And for and we put comma. And Z, Z is not equal to 0. 0 is an integer, but this cannot be 0. Q cannot, sorry, not Z. It is Q. Q cannot be 0. Q cannot be 0. So this is how we explain rational numbers. Q is rational number. A rational number is a number which can be written in the form of P over Q, where this line shows where P and Q belong to integers and Q is not equal to 0. So this is the definition in the form of this set equation. Now let us see what numbers are included in the rational numbers. Now, all integers are rational numbers. All integers are rational numbers. You will say how? How can 2 be a rational number? 2 is an integer. How can 2 be a rational number? How can we write it in the form of fraction? We can write it in the form of fraction. If I write 1 under it, 2 over 1, what is the answer? 2. So 2 can be written in the form of fraction. And if I write it 2 over 1, if I write it 4 over 2, what is the answer? 2. So 2 can be written in the form of fraction. And if I write it 6 over 3, what is the answer? 2. So 2 can be written in the form of fraction, although 2 is an integer. So 2 is a rational number also because it can be written in the form of a fraction. So all integers are rational numbers. Now, 0 is an integer. How can we write it in the form of fraction? 0. I don't know. 0 over 1 is 0. A 0 over 20 is 0. 0 over 100 is 0. 0 divided by any number is 0. So 0 can be written in the form of fraction. So this is also 0, this is also 0, and this is also 0. So 0 can be written in the form of fraction. Similarly, negative numbers. Negative numbers like minus 2 over 3 are 2 over minus 3 or minus 2 over minus 3. So they can also be written in the form of a fraction. So they are also rational numbers. Now let's go to the next category of rational numbers. What is the next category of rational numbers? Yes, decimals. Decimals which are terminating decimals and which are repeating and non-terminating decimals. These both kinds of decimals are rational numbers. Now, what are terminating decimals and what are repeating decimals? Let me explain. Okay, 1 over 2 changes fraction into decimal. What will be the answer? 0.5? Very simple. This is 0.5. This is terminating decimal. When we have solved it, we have cut it off here. The answer is 0.5. Or 1 over 4. What is the answer? 0.25. Just divide it. You will get 0.25. We have terminated it here. Okay? Then is 1 over 5, this fraction. What is the answer? 0.2. Terminating decimal. It has terminated. When we have solved it, the decimal has terminated. After the decimal point, we have 1 digit. Here, after the decimal point, we have 1 digit. Here, after the decimal point, we have 2 digits. But we have terminated it here. Then, next is 1 over 8. Solve it. You will get 0.125. 3 digits after decimal, but terminating. Then 1 over 10. 1 over 10. What is the answer? 0.1, but terminating decimal. So these are some of the examples of terminating decimals. And these terminating decimals 0.5, 0.25, 0.1, 0.125, 0.2, they are all rational numbers because they can be written in the form of fraction. Now 0.25 can be converted to 1 over 5. 0.125 can be converted to 1 over 8. 0.1 can be converted to 1 over 10. 0.25 can be converted to 1 over 4. 0.5 can be converted to 1 over 2. So these decimals, which are terminating decimals, they can be converted into fractions. So they are rational numbers because they are fractions, a different form of fractions. So terminating decimals are fractions. Now let's go ahead and see the repeating decimals. What are repeating decimals? They are also rational numbers. Now, 1 over 3, what is the answer? 0.33333. It keeps on going. It keeps on going, but this digit 3 is repeating. This digit 3 is repeating. So this kind of decimal is called repeating decimal, but non-terminating. It does not terminate. Like when we divided 1 by 2, 1 over 2 fraction, the answer was 0.5. It terminated. It terminated, but this is not terminating. It keeps on going, but the same number is repeating. So there is a pattern. एक खास पैटर्न से ये रिपीट हो रहा है. 3 एक नंबर रिपीट होता जा रहा है, मगर ये खत्म नहीं हो रहा, तो ये दिस इज रिपीटिंग बट नॉन टर्मिनेटिंग, टर्मिनेट नहीं हो रहा। ठीक है, कोई और एग्जांपल लें आप रिपीटिंग और नॉन टर्मिनेटिंग की। 1/6 करके देखें क्या आंसर आएगा। 1 6 6 6 6, it keeps on repeating, so there is a pattern. It keeps on repeating, but it is non-terminating, it does not terminate, so this is also a rational number. Okay, then take some other example like 1/7. 1/7. 1/7 is equal to G. 7 ones are 7, 7 fours are 28, 7 twos are 14, 7 eights are 56, then 7 fives are 35, 7 sevens are 49, again 7 ones are 7, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7. 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7. It keeps on going unendingly, non-terminating decimal, but it is repeating. How many digits are repeating? 6. 1, 2, 3, 4, 5, 6. 6. So this is the period. This, I mean, the number of digits which are repeating is called period. So period is 6 here. In case of 1/3, it was only 1. 0.3333. Only one digit was repeating. Here, 6 digits are repeating. So this is also a rational number because it can be converted into fraction. Then is any other number which is repeating and non-terminating. Okay, divide 1/9. What will you get? You will get 0.11111. Yes, 1 is repeating and is non-terminating. So this is also a rational number. This decimal is also rational number. Okay, divide 1/11. 1/11. What will you get? 0.9090909. It keeps on repeating. This pair, 2 digits are repeating. So there is a pattern. So this is also a rational number because it is a repeating and non-terminating decimal. Okay. Can you give me some other example also? Yes. What about 2/3? 0.666666 keeps on repeating. So these are the examples of decimals which are rational numbers. There are two types of decimals which are rational numbers. First is terminating decimal. We saw it in case of 1/2, in case of 1/5, in case of 1/8, in case of 1/10, right? In this case, the answer is terminating decimal. And in this case, the answer is repeating and non-terminating decimal. So these two types of decimals are rational numbers because they can be written in the form of a fraction, in the form of P/Q. Now let's go ahead. So we have learned so far that all integers, all whole numbers, all natural numbers, because when we say all integers, it means all natural numbers, all whole numbers, and all negative numbers and zero, they are rational numbers. All integers are rational numbers, and all decimals which are terminating and which are repeating and non-terminating, they are also rational numbers. Now, what else? If I write 2 whole 3 over 4, is it a rational number? It's a mixed fraction. Is it a rational number? Yes, it is a rational number, because you can write it 4 twos are 8 plus 3, 11 over 4. 11 over 4 is a fraction. So rational numbers are fractions. So this is a fraction. So mixed numbers are also rational numbers, right? Okay. Then next is, what about percentage? If I write 35%, is it a rational number? Yes, it is a rational number, because what is 35%? 35% is equal to 35 over 100. This is 35%. So this is a fraction. So percentages are also fraction. They are also rational numbers because they are fractions. Okay. What about this square root of 1? What is the answer of square root of 1? 1. What about this? Square root of 4. What is the answer? 2. What about this? Square root of 9. What is the answer? 3. What about this? Square root of 16. Answer is 4. What about this? Square root of 25. Answer is 5. What about this? Square root of 36. Answer is 6. Is square root of 1 a rational number? And square root of 4, square root of 9, and for that matter, square root of 16, 25, and 36, all these square roots, are they rational numbers? Yes, they are rational numbers. Because when you solve this square root of 1, you get 1. 1 is an integer, and all integers are rational numbers. Similarly, when you solve square root of 4, you get 2, and 2 is an integer. So 2 can be written in the form of a fraction, which is a rational number. When you solve 9, you get 3. 3 is an integer, so rational number. Similarly, 4, integer, 5, integer, 6, integer. So they are rational numbers. Now, can you see this? That 1, 4, 9, 16, 25, and 36. What are they? They are perfect squares. What are they? They are perfect squares. What is a perfect square? Perfect square is a number which you get when a number is multiplied with itself. When a number is multiplied by itself. Like, you get 4 when 2 is multiplied by 2. You get 9 when 3 is multiplied by 3. You get 16 when 4 is multiplied by 4. You get 25 when 5 is multiplied by 5. You get 36 when 6 is multiplied by 6. So when a number is multiplied by itself, what you get is perfect square. So 36 is a perfect square. 25 is a perfect square. 16 is a perfect square. 1, 4, 9, perfect square. 79, sorry, 49. 7 into 7 is 49. So 49 is a perfect square. 8 multiplied by 8 is 64. 64 is a perfect square. 9 multiplied by 9 is 81. So 81 is a perfect square. 10 multiplied by 10 is 100. So 100 is a perfect square. 11 multiplied by 11, 121. So 121 is a perfect square. And 12 multiplied by 12 is 144. So 144 is a perfect square. 13 multiplied by 13 is 169. So 169 is a perfect square. 14 multiplied by 14 is 196. So 196 is a perfect square. 15 into 15 is 225. So 225 is a perfect square. 16 into 16 is 256. So 256 is a perfect square. 17 into 17 is 289. So 289 is a perfect square. Similarly, 20 into 20 is 400. So 400 is a perfect square. So when a number is multiplied by itself, what the product you get is a perfect square. So all perfect squares, when you take square root of those perfect squares, they are rational numbers. Square root of 1 is a rational number. Square root of 4 is a rational number. Square root of 9 is a rational number. Square root of 16 is a rational number. Square root of 25, square root of 36, 49, 64, 81, 100, 121, 144. They are perfect squares. So when you take square root of the perfect squares, they become rational numbers. Now, what about square root of 2 and square root of 3 and square root of 5 and square root of 6, square root of 7, square root of 8, square root of 2? What is the answer? When you take square root of 2, what answer do you get? You get, ask the calculator. It will give you 1.4142 and 1, 5, 5, 6, so on. See the decibel. Decibel is non-terminating. It is not terminating, but it is not repeating. It is not repeating. It is not repeating. There is no pattern. After decimal, there is no pattern in the digits. They are not repeating, but they are non-terminating. It keeps on going. It does not end. So square root of 2 is not a perfect square. 1 is a perfect square, 4 is a perfect square, 2 is not a perfect square because you do not have any whole number which is multiplied by itself to get 2. When you multiply 1 by 1, you get 1. When you multiply 2 by 2, you get 4. So there is no whole number which when multiplied by itself gives you 2. So 2 is not a perfect square. What about 3? Square root of 3. By the way, 2 itself is a rational number because 2 is integer. But square root of 2 is not a rational number because it cannot be written in the form of a fraction because it does not terminate and it does not repeat. ना तो ये repeat हो रहा है ना ये terminate हो रहा है. जब terminate ही नहीं हो रहा तो आप इसको fraction में कैसे लिख सकते हैं? तो ये फ्रैक्शन में नहीं लिखा जा सकता. तो जो फ्रैक्शन में नहीं लिखा जा सकता वो रैशनल नंबर नहीं है, ये इरैशनल नंबर है. सिमिलरली स्क्वायर रूट ऑफ 3, स्क्वायर रूट ऑफ 3 भी जब आप कैलकुलेटर से पूछेंगे तो वो आपको बताएगा 1.7320. I have written it somewhere, 503, so on. It does not terminate, and it does not repeat. There is no pattern. So this is also not a rational number. What about square root of 5? This is not a perfect number. So 2, 3, 5 are not perfect numbers. And square root of 5, you can ask the calculator, it will give you 2.236, 0679, and so on. Keep going. There's no pattern. There's no repetition. So no digit is repeating. So it is an irrational number. It is not a rational number. Now, the conclusion we have drawn from here is that perfect squares are rational numbers. Perfect square, the square root of perfect squares is a rational number. And the square root of a number, which is not a perfect square, is not a rational number. Square root of 2 is not a rational number. Square root of 3, square root of 5, square root of 6, square root of 7, square root of 8, they are not perfect squares. So they are irrational number. Square root of 9, yes, rational, because 9 is a perfect square. Why? Because when you multiply 3 with 3, you get 9. So 9 is a perfect square. So square root of 9 is a rational number. But square root of 8, 7, 6, 5, 3, and 2, they are not perfect squares. So their square root is an irrational number. So they are irrational numbers. Square root of 2, 3, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, but 16, no. 16 is a square root of 16 is a rational number because 4 multiplied by 4 is 16 and 16 is a perfect square. When you solve it, you will get 4. Now, if we go ahead, what about cube root? What about this? Cube root of 8. Is it a rational number? This 3 means that there is a number which when you multiply 3 times, you will get 8. So, what is that number? 3, 2 into 2 into 2. 2 into 2 is 4, 4 into 2 is 8. This 3 means that you have to multiply a number 3 times, 2 into 2 into 2, and you get 8. So what is the answer of 3? This is called cube root. When you put 3 here, this shows cube root, and this sign of root and 3, this we call it cube root. Cube root of 8. So what is the answer of cube root of 8? The answer is 2. The answer is 2. And what is the cube root of 27? Cube root of 27. Which number is multiplied by itself 3 times to give you 27? 3. 3 multiplied by 3 multiplied by 3. 3 threes are 9, 9 threes are 27. Okay? So, what is the answer of cube root of 27? The answer is 3. And 3 is an integer. So, this is a rational number. So, cube root of 27 is a rational number. And cube root of 8 is a rational number. But what about cube root of 4? What about cube root of 4? Is there any number which, when multiplied with itself 3 times, gives you 4? No, there is no number. So cube root of 4 is always a decimal which is not repeating and not terminating. It does not terminate, but does not repeat. When you will solve it, you will get an answer where the decimal will be non-repeating, non-terminating. So this is an irrational number. Okay. And what about, by the way, fourth root of 67? Fourth root of 67. What does it mean? Which number is multiplied by 4 times to give you 16? 2. 2 into 2 into 2 into 2. 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16. 16. So, fourth root of 16, the answer is 2. What is the answer? Answer is 2. And 2 is an integer. Therefore, fourth root of 16 is a rational number. It is a rational number. Okay? What about fifth root of 32? Fifth root of 32. Which number is multiplied 5 times with itself to give you 32? 2. 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. 5 times. 2 twos are 4, 4 twos are 8, 8 twos are 16, 16 twos are 32. So, fifth root of 32 is equal to 2. And 2 is an integer. So, therefore, fifth root of 32 is a rational number. I hope up till here you have understood that the square roots of perfect squares, that is 1, 4, 9, 16, 25, 36, etc., are rational numbers. Cube roots of perfect cubes, that is cube root of 8, 2 into 2 into 2. Cube root of 27, 3 into 3 into 3. Cube root of 64. Cube root of 64. So, which number is multiplied by itself 3 times to yield 64? 4. Cube root of 4 multiplied by 4 multiplied by 4. 4 fours are 16, 16 fours are 64. So the cube root of 64, the answer is 4. And 4 is an integer. So cube root of 64 is a rational number. Okay. So the perfect cube, the perfect squares, the perfect fourth roots, the perfect fifth roots, they are all rational numbers. But the numbers other than the perfect squares, perfect cubes, etc., when you take the square root or cube root of those numbers, you do not get a rational number because the answer is a decimal which is non-terminating, non-repeating. So that will not be a rational number, that will be an irrational number. Let's go ahead. So far, we have learned that number one, all integers are rational numbers. Number 2, all fractions, all fractions, all fractions are rational numbers. Number 3, terminating decimals. Terminating decimals. Terminating decimals. They are also rational numbers. Number 4, repeating but non-terminating decimals. Repeating but non-terminating decimals. Okay? So that is number 4. They are also rational numbers. And number 5, mixed numbers. Mixed numbers. They are also rational numbers. We have learned that 2 whole 3 over 4 is a rational number. 2 fours are 8 plus 3, 11 over 4. So this is a rational number. So mixed numbers are also rational numbers. Number 6, we have learned percentages. Percentages are also rational numbers. We have learned that 35% means 35 over 100. 35 over 100 is a fraction, so it is a rational number. And then we have learned that square roots of perfect squares. Square roots of perfect squares. Of perfect squares. Square roots of perfect squares. I mean square root of 1, square root of 4, square root of 9, square root of 1, square root of 4, square root of 9, square root of 16, square root of 100. They are all rational numbers. Then, if you allow me, I'll erase it. Then we have learned cube roots, number 8. Cube roots of perfect cubes. Cube roots of perfect cubes. Of perfect cubes. Like cube root, we write like this, 3 and this symbol of root. Cube root of 1 is a perfect, 1 is a perfect cube. 1 multiplied by 1 multiplied by 1. If you multiply 1 3 times with itself, you get 1. So this is a perfect cube. 1 is a perfect cube. Cube root of 8. And then cube root of 27. And then cube root of 64. Then cube root of 125. 64 we have learned. 4 into 4 into 4. 125. 5 into 5 into 5. Then cube root of this cube root of 6 into 6 into 6. क्या बनेगा जी? Cube root 6 into 6 into 6. 216. 216. Right? So all perfect cubes are when you take cube root of all the perfect cubes. What are the perfect cubes? 1, 8, 27, 64, 125, 216, and then 216 after you have 343. 7 into 7 into 7. Then you have 512 perfect cube. 8 into 8 into 8 is 512. Then you have 729. 9 into 9 into 9. So 729 is also a perfect cube. Then you have 1000. 10 into 10 into 10. That is also a perfect cube. So perfect cubes are when the cube root of the perfect cubes is taken, that becomes a rational number. Then fourth root, we have number 9. Fourth root. Fourth root of 16. By the way, fourth root of 1 is also correct. 1 into 1 into 1 into 1 is 1. Fourth root of 16. 2 into 2 into 2 into 2. And fourth root of 81. 3 into 3 into 3 into 3. 4 times. 3 into 3 is 9. 9 into 3 is 27. 27 into 3 is 81. Then fourth root of 4 into 4 into 4. 4 into 4 into 4 into 4. 64. 4 into 4 is 16. Into 4 is 64. And into 4 is 256. So fourth root of 256 is also a rational number. Okay, because the answer is 4. Here the answer is 3. Here the answer is 2. Okay, so this is also a rational number. Okay, let's go ahead. And similarly, fifth root and sixth root are perfect roots. Okay, so these are rational numbers. Let me once again explain what is a rational number. A rational number is a fraction, simple fraction, where the numerator must be an integer. Numerator must be an integer. And denominator must also be an integer, but a non-zero integer. Non-zero integer. So very simple. So a rational number is a number which can be written in the form of a fraction, that is p over q, where p and q both are integers, integer, and q is not zero. So non-zero integer. P over q and q is not equal to 0. So that is the definition of rational number. And natural numbers, whole numbers, integers, they are all found inside the rational numbers. Integers, all integers are rational numbers. All whole numbers are rational numbers because all whole numbers are integers. All natural numbers are rational numbers because all rational numbers are integers. Since all integers are rational numbers, therefore whole numbers and natural numbers are also rational numbers. And what is additional in rational numbers? Natural numbers, whole numbers, and integers, they are rational numbers. But what is additional? Additional, I have told you, fraction. In integers, you do not have fraction. Decimal, in integers, you do not have decimal. So decimal and fraction are additional things in rational numbers, and square roots of perfect squares, cube roots of perfect cubes, fourth roots of perfect numbers, which can be calculated, and you get answer of a whole number. So, and mixed numbers are also rational numbers, which are not integers. Percentages are rational numbers because they can be written in the form of fraction, 35 or 100, I told you. So, I hope you must have understood the concept of rational numbers and irrational numbers also. I have told you what are irrational numbers, which cannot be written in the form of P over Q. What are those? The numbers which have a decimal which is non-repeating and non-terminating, like square root of 2. What is the answer of square root of 2? You get a decimal which is non-terminating, non-repeating. Square root of 3, square root of 5, square root of 7, 8. Square root of all those numbers. Now listen very carefully. Square root of all those numbers which are not perfect squares are irrational numbers. Otherwise, 2 otherwise is a rational number because 2 is an integer and it can be written in the form of 2 over 1. So 2 is a rational number. But when you take square root of 2, it becomes irrational because square root of 2 is 1.4142, etc., etc. It keeps on going, non-repeating, non-terminating. So that becomes irrational. When you take square root of a number which is not a perfect square, that is an irrational number. When you take a cube root of a number which is not a perfect cube, that becomes an irrational number. When you take a fourth root of a number which is not a perfect number, which can be calculated to give you the answer in a whole number, that is an irrational number. So these are irrational numbers, cannot be written in the form of P over Q. वो फ्रैक्शन में लिखे नहीं जा सकते. ठीक है. अच्छा, अब और कुछ ऐसे हैं जो मैं आपको बता देता हूं. मसलन आपने मैथ में पाई पढ़ा है. पाई की वैल्यू पता क्या होती है? 3.1415 और क्या है इसके आगे चलती जाती है, ये खत्म नहीं होती है. कहीं मैंने लिखी हुई है बट मुझे यहां से अभी, यस, 3.1415 92653 and keeps on going. This is the value of pi. So pi is an irrational number because the decimal is non-terminating and non-repeating. So pi is an irrational. Then E, which is Euler's number. Like pi, this is also a number. You will learn in the higher classes. अभी आपको इसका नहीं पता Euler's number क्या होता है, बट इसकी वैल्यू मैं बताता हूँ आपको. 2.718 2818 28 etc. So it is non-terminating, non-repeating. So E, Euler's number, is also an irrational number. Then is phi. It is called golden ratio, and its value is 1.6180539 and so on and so forth. It keeps going. It's also unending. So this is also an irrational number. So pi, Euler's number, and phi, they are irrational numbers. Similarly, square root of 2 is an irrational number because you have seen that its value is 1.4142 and so on and so forth. 1.4142 1356 and it keeps on going. So non-repeating, non-terminating decimal. So this is also an irrational number. So these numbers cannot be written in the form of a fraction. इनको आप फ्रैक्शन में नहीं लिख सकते. क्यों? क्योंकि इनका ये डेसिमल टर्मिनेट नहीं हो रहा और रिपीट भी नहीं हो रहा, लिहाजा इनके नीचे आप कुछ नहीं लिख सकते. क्योंकि अगर आप यहाँ पे 1 लिख के इनके नीचे जीरोस डालेंगे तो कितनी जीरो, ये तो खत्म ही नहीं हो रहा, ये आगे चलता जाएगा, फिर जीरो भी आगे चलता जाएगा. ये तो नॉन टर्मिनेटिंग है, लामुतनाही सिलसिला है. तो इसलिए इसको फ्रैक्शन में नहीं लिख सकते. तो ये इर्रेशनल नंबर्स. तो आपने रैशनल और इर्रेशनल नंबर सीखे. पहले आपने सीखे थे नेचुरल नंबर, फिर होल नंबर, फिर इंटीजर्स, फिर रैशनल नंबर और इर्रेशनल नंबर. अब ये पांचों नंबर जो हैं ये सारे, इनको हम रियल नंबर्स कहते हैं. और उस रियल नंबर्स को, अच्छा, जो इर्रेशनल नंबर है पहले उसको हम ये क्यू डैश से करते हैं रिप्रेजेंट, क्यू डैश. जो रैशनल नंबर थे उनको क्यू से करते थे, इर्रेशनल नंबर को क्यू डैश से हम शो करते हैं, क्यू डैश. ठीक है. और रियल नंबर को कैपिटल आर से. रियल नंबर कौन कौन से हैं? सारे मिला लें आप, नेचुरल नंबर्स, होल नंबर्स, इंटीजर्स, रैशनल नंबर्स एंड इर्रेशनल नंबर्स. ये पांचों किस्में जो हैं ये दे आर ऑल रियल नंबर्स. दे आर ऑल रियल नंबर्स. और ये अगर मैं आपको अब इसमें ये बता दूं तो ये देखें, जो नेचुरल नंबर हैं वो सारे के सारे पाए जाते हैं होल नंबर में. नेचुरल नंबर इज ए सबसेट ऑफ होल नंबर्स. और होल नंबर सारे के सारे पाए जाते हैं इंटीजर्स में. होल नंबर्स आर सबसेट ऑफ इंटीजर. और इंटीजर सारे के सारे पाए जाते हैं रैशनल नंबर्स में. ठीक है. और रैशनल नंबर सारे के सारे पाए जाते हैं रियल नंबर. So natural number is a subset of whole number is a subset of integers is a subset of rational numbers, and rational numbers are a subset of real numbers, and real numbers are a subset of complex numbers. ये आप बाद में सीखेंगे बड़ी क्लासों में जाके कॉम्प्लेक्स नंबर्स क्या होते हैं. तो ये आपको याद रखना है कि सारे नेचुरल नंबर जो हैं होल नंबर में मौजूद हैं, सारे होल नंबर जो हैं वो इंटीजर्स में मौजूद हैं, सारे इंटीजर्स जो हैं वो रैशनल नंबर्स में मौजूद हैं, सारे रैशनल नंबर जो हैं वो रियल नंबर में मौजूद हैं, और सारे रियल नंबर कॉम्प्लेक्स में मौजूद हैं. इसमें इर्रेशनल मैंने नहीं लिखा क्योंकि ये रियल नंबर जो हैं, जो इर्रेशनल हैं वो अलग से लिखेंगे आप. क्यू डैश इज ए सबसेट ऑफ रियल नंबर्स, क्योंकि क्यू डैश ये उसका सबसेट नहीं है. ठीक है. ये अलहदा है और ये अलहदा है. तो क्यू डैश इज ए सबसेट ऑफ रियल नंबर्स. जिस तरह क्यू इज ए सबसेट ऑफ रियल नंबर्स, क्यू डैश भी सबसेट है रियल नंबर्स का. ठीक है. इर्रेशनल नंबर भी रियल नंबर में पाए जाते हैं और रैशनल नंबर भी रियल नंबर में पाए जाते हैं. ठीक है. और ये इज ए सबसेट ऑफ कॉम्प्लेक्स नंबर्स. तो ये उम्मीद है आपको समझ आ गई होगी. और मजीद अगर कोई कंफ्यूजन इसमें रह गई है तो आप दोबारा मेरे से पूछ सकते हैं. अब इसके बाद अगली जो इसके ऊपर चीज रह गई है वो है कि इनको आप नंबर लाइन के ऊपर कैसे प्लेस या लोकेट करते हैं, वो इंशाल्लाह नेक्स्ट लेक्चर में बताऊंगा. अब बस मुझे इजाजत दें. थैंक यू वेरी मच एंड अल्लाह हाफिज.